Ah, well done. That's 5 in a row. You won.
We recently worked on an awesome project where we built a 4-in-a-row game machine for Harper Adams University to have as a feature piece in their foyer of their university.
If you put it in there, it's just going to put another on top of it. So the four, this and I've got. Hold on, we're doing 5 and 2. What's it this?
Now, we are planning to make that project more exciting. As a part of its development, we did create 3D models and 3D content in order to design the solution. As part of our analysing and discussing the design and discussing the physics and checking how the balls are going to roll down various tubes and channels, we use STAGEit to simulate some of that.
One of the questions is, how are these balls going to stack down here when they come through, and what will that visually look like?
Well, we're taking that a step further today because STAGEit does have the ability to create a real-world digital twin. What is a digital twin, you ask? Well, the proper definition of a digital twin is something that simulates a real-world physical object. So in the 4-in-a-row machine's case, we've got a physical 3-dimensional piece of kit, and then it's got bits of software running on it, and it's got servos that move. So it's got 7 servos, 1 for each tube. It's got a servo for the color picker and a color sensor, and it's got a servo for the game selector. It's got a vacuum system, and it's got relays and various other bits of kit that run that. A digital twin of that would be the model plus a simulation, ideally a live simulation of what's happening in the real world. And we have created that digital twin out of the model that we built. So we've animated the servo doors and we've extended STAGEit so that it can be connected to via sockets or MQTT or HTTPS API. And it can stream data to and from a real world object. So you can use STAGEit to monitor and interact with a real world item. Here's a little video of me just showing the progress on the digital twin model where we're just setting up the relevant commands to do the relevant things before they get wired up to the actual machine.
This is the digital twin of the model we're going to take to the MTC. So the elements that are going to be functional are each of the individual tube doors, the lower ball flap and the spinner, as well as a ball spawner. The game is fundamentally controlled by a Raspberry Pi, which hosts the front-end GUI. It also manages the gameplay, which then sends commands to an Arduino, which is placed on the back of this, which controls all the servos here and these 2 servos up here, as well as the color sensor and the relays in the base, which run the vacuum system. We've got the Apple Vision Pro interface here, which we're going to scale down so that we can place it on here, just so that you can play the game from the digital twin. It's 2-way, we can send commands to it and receive commands from it. The Pi has been set up as a web server, so we've got web sockets open for it so that we're able to mirror the game elsewhere. STAGEit will be connected to the real world robot via web sockets. So it'll be listening for all the commands that are currently being sent to the Arduino, which is the automation controller. Now, those self-same commands can then be injected into STAGEit, and STAGEit will mirror what will be happening on the robot. We're able to actually input some of the basic commands on an interface within STAGEit to trigger the digital twin, but these will obviously be happening over WebSockets.
So that's it. We really are excited about how STAGEit can be used in the engineering and manufacturing world, how these sorts of technologies can really help people diagnose, train on, preview, design all these expensive implementations that you might have going on. If you want to have a go on it, come to the MTC on the 31st of October. We'll have everything there and we'll be very willing to let you have a go. Thanks for watching.